y-axis, z-axis. Then it explodes here. So explosion. So what is explosion? Explosion is an internal phenomenon because what are the forces acting? The forces will be an internal forces because all their chemical reaction, no? It's an internal forces. So because of that, so we'll get a fragments. One fragment will move like this. One fragment will move like this. It will explode equally into equal fragments himself is telling. What about the third fragment? How do it will move? So equal kinetic energy. So they are having same kinetic energy. So let's put K. Because of kinetic energy, they will have momentum. How kinetic energy and momentum are related? So they will have the velocity C, B, B, B. Kinetic energy, I should not show direction. Let's go for it. So then, what is the kinetic energy equal to? M by 4 by 2 B square. This was the basic idea. This one. So this will become mv square by 8. Then I wanted, so there's the individual, what is the momentum of individual particle? We'll check it. Like an expression for V. V is what? 8k by m. So what is the momentum of individual particle? Px should be equal to m by 4 into V. This should also be equal to, I have space here, Px equal to Py equal to P. Only magnitudes. That should be equal to, mass of each fragment is m by 4 and the speed is V. We have just now calculated. So this will become 8 mk by 16. Mk by 2. If you're finding difficult, no, you can apply this method. So there's a initial momentum of individual fragment here. Now it's asking center of mass of system after collision will be. Okay, let's go for it. Now the explosion has taken place. What is a basic explosion? So what forces are responsible for explosion? The chemical forces. The chemical forces and what all the chemical forces that are acting, the molecular forces, they'll become internal to the system. So therefore, during explosion, what all the like a molecular forces that are acting, they'll treated as an internal force. And due to internal force, center of mass will not accelerate. So what do you expect? The center of mass after the explosion. Initially it was a test, now also it's going to be a test. Center of mass will not move. So center of mass where it is going to be there only. The reason for that, what is the reason we should give? During explosion, internal forces will act. During explosion, internal molecular forces, let me write it, molecular forces act here. And we know due to internal force, center of mass will not accelerate. So what was initially system was a test. So finally after explosion also, center of mass will be there only. Can we apply conservation of linear momentum? Yes, the net force on the system is 0. So what direction you will apply conservation of momentum? In a space. So initial momentum equal to final momentum. So what is the initial momentum? 0. Final momentum. We have that one. Px I cap, Py j cap, Pz k cap, plus the momentum of the fourth fragment we don't know, P4 bar. So how it should move? That's what we are making a guess here. Now do we know this, all this value? Do we know the momentum? Yes, it will be how much it is? Root m by k this I cap. So somewhere in a space, the fourth fragment will move. Speed of fourth fragment is asking. There's a momentum what we have. I want speed, so what shall I do? I think what is the momentum? How you define momentum? Momentum should be equal to the fourth fragment will have mass m by 4 into v4, no? So what is the magnitude of this? Will be root 3. Okay, now substitute this. So now due to explosion, the center of mass will not shift. That's the basic idea what we have brought it here. Okay, now V4 is needed. So this is equal to 4 into PV4 by M. Vp, this is equal to M or 3 mk by 2. K by M. What is V4? Speed of fourth fragment. Total energy released. What do you mean by total energy released? So what was the state of center of mass? Center of mass was at rest. Now due to explosion, center of mass will not shift. The fragments start moving. So the kinetic energy of fragments is nothing but the total energy released here. So what is the next part of the thing? Energy.
Speed of fourth fragment is
Energy. Energy release should be equal to kinetic energy of fragments.
Sir, 2 under root 60.
Sir, speed should.
2 will be there, huh?
Yeah, 1
Yes,
extra 2 should be.
Yes, sir. 2 into under root 60. Yes, sir.
2 into here 1 2 is missing, no? Yeah, fine. Or we can send total, no? Okay, let's write based on this option. Okay, now kinetic energy of fragments. What is the kinetic energy of fragments? The 3 fragments, 3 of them fly with perpendicular to each other with same kinetic energy. Okay, k plus k plus k. The fourth one is what? K4. How to calculate the kinetic energy of the fourth fragment?
Velocity we have.
mv4 square. So mass of the particle is m by 4. Okay, then we know the speed v4. So this should be equal to 3k plus this will be m by 4 v4 just now we have brought it 2 6 square, no? So this will be 4
K.
6K, sir.
6k only will come.
Yes, sir.
There's a total energy released here. So now center of mass, what happens? Though the fragments will be moving, center of mass will be there only. So center of mass where it is there. So initial portion where you kept that particular explosive will be there. I think during Deepavali festival it will happen. Now that particular flower pot, no? Also some other things are there where it will get burst. So usually it will be at rest, no? So you explode it. Where the center of mass of system will be. Where initially that particular explosive there will be there only. The fragments will be moving with the different velocities in different direction. Any doubt if you have, you can clarify here. So that calculation of center of mass, no, it is a just mere mathematical one. I think, are you getting now that the real concepts are here now? But I don't know the book's material. They have dumped more on finding center of mass, finding the center of mass. But final exam advance, none of the questions came on finding the center of mass. You should know the center of mass of various objects. That's all. The motion of center of mass, conservation of momentum. These are the things which are going to help us a lot for the coming chapters. Not like, see, center of mass of what, like solid cone, hollow cone, some well-defined geometrical shapes. If you know it, is more than enough. But it got deviated because they are like a more mass-based, so they are dumped questions like anything. Today, I suggest to everyone, don't take any numericals on finding center of mass of an object because it is of no use. Already you know for a triangular plate where it is there, square plate you know, semicircular plate. Just if you know it is enough. Beyond that, not needed for us.
Sir, for paraboloid and all those shapes not required, sir?
It's there, okay, workout. But
Okay, sir.
now today you have to focus on the